Okay, so what it's gonna be like is that I would be solving this question, reverse linked list, but I would be doing this question in like two ways. So first approach will be the recursive way, and no, let's start with the iterative way, and then the second approach can be the recursive way. So at the moment I am currently doing trees on like the theory of it, the code and everything, and revising linked list, so it's going hand in hand so that I don't forget the concepts behind. So yeah, let's reverse the linked list. But as you can see, I have done this question before, but for the revision purpose, let's do this again. So I have to reverse the linked list. Now the thing is that there can be two ways. That's why there is a follow up. Either iteratively or recursively, could you implement both? So let's try to understand both the approaches, and let's implement both the approaches. So first thing that has to be clear is what I would be doing is I would be taking three pointers. First pointer is going to be a previous pointer that is going to point towards null. Second pointer would be the current pointer that is going to point at the head, and the next pointer would be named as next, that would be pointing towards current's next. So for example, if we see at example 1 here in this question, so my previous pointer would be before 1, what's that? Null. My current pointer would be at 1, that's the head, and my next pointer would be at 2, that is current dot next. So in that way I'm going to divide those three pointers. I won't be using any extra space. So yeah, the space complexity can be O of 1, and yeah, so let's try to do it. So first of all, let's put out the pointers. Basically what the thing is that what we have at the moment is given like the head. So basically we don't have a linked list given to us. What we are given is the head. So what the lead code is going to do is it's going to be like take the head and then move ahead with it, like dot next dot next dot next. So that's how it's going to get the whole linked list. So given the head, I can say my current can be head, and given the like current, I can say my previous can be null, right? My previous can be null, and then given this, I would say my next can be current dot next. Alright, cool. So let's have a null pointer check so that we don't get the null pointer exception thing, which is that what if my head is null? So I can't be doing next, like, because if my head is null then my current is null, so I can't move ahead with next, so it would be giving an error, so we don't want that. So if head equals null, what we have to do is we have to be like, alright, it's fine, return head, that's it. Cool. Yeah, so when we have our head with us, what we can do next is we can say, alright, we have our head, we have the null pointer check for it. So next thing that we have to do is have a while loop, because we don't know how long the linked list can be. So we'll have a while loop wherein we'll say, alright, so till the moment our current is not equals to null, keep moving ahead. What do I mean by that is, initially what's gonna happen is I'm gonna say, if I'm gonna do it in the same space, no extra space needed, like I'm gonna make changes inside this linked list only, I'm gonna say, alright, what is next to 5? Next to 5 I have null, right? So if I'm gonna reverse the linked list, my head is gonna be the tail, of course, and my tail is gonna be the head. That's something else. The main point is that if my 1 is gonna be the tail of the linked list because I'm reversing it, something next to 1 has to be null. Alright, so if I say, cool, something next to 1 is null, so I'm gonna say that Alright, something next to 1 is null. Now I have to make sure that I keep moving ahead. Yeah, so when I move ahead, my previous was initially null, it's gonna be at 1. When I'm gonna move ahead, my current would be the 2 and my next would be the 3. I move ahead doing the same operation. Here is my previous at 2, my current is at 3, my next is at 4. I move ahead again, my previous is at 3, my current is at 4, my next is at 5. I move ahead again, my previous is at 4, my current is at 5, my null is my next is at null. Alright, so I move ahead again, and what happens is my current becomes what my next was, it becomes null. That's the case when we're gonna stop, but also my previous becomes 5. So that means I'm gonna be returning previous, because now my previous will be the node that is gonna contain the head. So while current is not null, till the time it's not null, keep moving ahead. The moment it's null, end the while loop. While it's not null, what we have to do is we have to say, alright, it's not null, so my current current's next has to be previous. Cool. The moment my current's next is previous, no, my once next is now null, I'm gonna say, cool, my previous is now my current. I moved ahead. Yeah, and my current, and here is the thing, as we saw that next is gonna get null soon. So let's have a check for it. If next is not null, yeah, if next is not null, then next can be next dot next. Cool. So then my current can be next. I mean, can be next above as well. Yeah. Cool. So just want to make sure that should I put this line below it or what, because now I guess it works, because initially my current is at head. I'm dealing with the null pointer thing right here, so my current is sorted, due to which my next is sorted as well, because it's gonna be the current dot next, so it's fine because it's gonna move ahead, of course, because current is not null. So my current can be next because here it's sorted. For the next iteration, I have to check for next, so it's fine. So yeah, it's good. It's good. So I'll be saying then you can just return a node that is the previous. Yeah. Yeah, works. Alright. So it works that way. Let's try to have the recursive approach now. So what's gonna be the recursive approach? So the main point for the recursive approach is to make a function that you can use again and again instead of a for loop. Yeah. So for the recursive approach, what we can do is we can be like, alright, let's have a base case for it first. Yeah. So for a recursive approach, we should be having a base case, we should be having a body, and then we have to call that recursive function inside the body. So let's have a base case. So the base case can be, first of all, let's make a function. Let's name it helper. Yeah. All it's gonna need is list node current and list node previous. Yeah. Cool. It needs a current, it needs a previous. My base case can be if my current gets to null. Yeah. If my current gets to null, what you have to do is you just have to return the previous. That's it. The moment my current gets to null, just return the previous, because that's what's happening. My current becomes null, previous lies at the last node, return that. you know. Alright, so I'm gonna return previous, that's fine. What's with the body now? So the body is gonna work the same way. I'll be taking the input, so I'll be saying for this particular iteration for the node 1, for that iteration I'll be like current dot next can be previous, previous can be null, and oh my bad, can be current, yeah. And let's have a check for next. I guess we'll have to create next here because we didn't take it, you know. This node next equals current dot next, but let's make sure that we don't mess up the order, because here I'm saying current dot next is previous, so this node next has to be current dot next now. It's gonna be a little bit messy. Wait. So yeah, cool. Yeah. So next is now sorted for the current dot next. Current dot next is now previous, and my next is having what initially was current's next, that was true, and my previous is now here, and my current dot next is previous, so current dot next is there now. Alright, it's fine, sorted. And let's have a null pointer check for next as well. Yeah, let's have that. I can say current equals next, yeah, and if next gets to null, is not till the time it's with next not equals null, next can be next dot next, yeah. Alright, so it's fine, the order seems fine. All we have to do is we have to return a value, because it's a function, so it's a list node function, it's a node type function, so we'll have to return a value. So what should we be returning? Thing is, when the base case hits, it's going to return the previous, it's going to return the last node. The following code would be waiting, so 5 is going to get returned, and then it needs to return something ahead to the further calls. So 4 has to be returned, 3 has to be returned. So initially for this particular iteration, previous was at 1. So we can just do one thing, we can return this function helper, because it's because initially this function is going to return a node that's previous. We can return the helper with it needs a current, so we have a current now for the next iteration. So now my current is at 2, so yeah, I can return it with current, and then I need a previous, so I can have a previous, because now my previous is at 1. So initially I had the body for the first iteration that was null and 1. Now I'll be passing the function for 1 and 2, then 2 and 3. It's gonna return everything. So yeah, initially previous is gonna get returned. So this function call is gonna wait for something. Suppose this is the last function call, so this at 5 the base case gets hit, previous is at 5, previous gets returned. So yeah, this return thing would now be having yeah, I guess this return thing is fine here. This return thing would be having a, like, the function is now getting an answer that is the node previous, I would say. Alright, let's see. Let's have this helper called right here. Yeah. helper we can pass head and null. We can pass head and null. We can just say return this. How about this? It works. So yeah, let's understand the flow of the code, what's happening. So I'm saying, cool, I did the swapping for the null and 1 thing. So initially now my previous is at 1, my current is at 2. Now I'm saying return something. Now the function gets called again, and my current was at 2, my previous was at 1. So this thing is gonna execute the same way. Yeah, now my previous would be at 2, my current would be at 3. I'm gonna again call the function. My previous would be at 3, my current would be at 4. I again call the function, my current is at 5, my previous is at 4. And I again call the function. Now my current is at null. Yeah, my previous is at 5. I again call the function, base case gets hit, current is null, I return previous, I return this 5. Yeah, so the call before that was waiting for something to get returned. What did I return? I returned a 5. Yeah, so this would be returning a 4. Yeah, no, the thing is, I returned a 5. Everything right there wanted something as the answer. So when I returned a 5, every function call is gonna get the 5 thing. 5 is gonna reach, 5 is gonna be like the head, of course. So I returned 5. So every code block for every recursive call is gonna get 5, returned up and up and up and up. So yeah, the recursion was going down the depth. What it got the answer was as 5. I returned previous. So 5 is now gonna jump up, up, up. So 5 is gonna go till the top. And yeah, I guess that would be returned at the top. So what I'm returning right here is the head. Of course, I'm returning 5 due to this function call. And that's the answer, because it needed a node to which it can traverse dot next dot next. So it's going to be like 5 next 4 next 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 next. So that's how the thing works, I guess. Let's see. Cool, it works. So yep,